Okay, so to solve for vertical asymptotes, you're dealing with rational functions. So if this is your rational function, to find the vertical asymptotes, you're only looking at the denominator. And your vertical asymptote is when the denominator cannot equal 0. So in order to solve it algebraically, you first set the denominator equal to 0. Obviously, x equals -3. So algebraically, it says that your vertical asymptote is equal to -3, or when x equals -3. You can also check that by doing it graphically. So if you have your graph, and you know that at -3, you're going to have a vertical asymptote. So you can go ahead and draw that in. And then you can check it on your calculator by plugging it into your calculator. And you get something that looks along the lines of this. So if we draw that in, you get a graph that looks like that, which shows that there is an asymptote there, but you can also check it by going to the table, and you'll see that when x is -3, where we said our asymptote was, there's an error. So that shows that there is an asymptote there. And you can do the same thing for a problem like this. So once again, you're only looking at the denominator. For this one, you'd have to factor it first. So you factor it out. So x plus 1, just kidding, x minus 1, and x plus 5. So x minus 1 equals 0, and x plus 5 equals 0. So x equals 1, and x equals -5. So for this case, you're going to have two vertical asymptotes at x equals 1 and x equals -5. You can again check this graphically. So if you say you have an asymptote at -5, and you have one at 1, you can draw those in. And then you can plug this into your calculator. And you get a graph that looks like this. So and since you know you have two vertical asymptotes, it's going to be splitting the graph into 3 parts, so you know that there's going to be 3 sections to the graph. So you know that your graph is coming out correctly. And then once again, you can go to your table to check to see the vertical asymptotes, and you'll see at -5, when x is equal to -5, there's an error, so that there is a vertical asymptote there. And when x is equal to 1, there's an error, so there's also an asymptote there.